The experiment is analysis of rotational spectra. The aim of the experiment is to find the rotational parameters of the molecule N2, that is nitrogen, by Raman rotational spectrum. The formula given is I is equals to h by 8 pi square bc, where h is your Planck's constant, b is your rotational constant, which we have to find using the graph, and c is the velocity of light. So the first step is we have to find the distance of each of these points 0, 50, 100 and 150 from this point, from the origin. So the point from the distance from 0 to 0 will be 0 itself, and now we will take from 0 to 50, that will be around 2.6. You see 2.6, and similarly you have to find the points for 100 and 150. So now using these values that we got, we are going to plot this graph, which is known as the calibration curve. Stop. So this is the scale reading which we are plotting from 0 to 10, and this is the wave number which we are plotting from 0 to 150. Now we need to fill this table in which this J represents your Stokes lines 0, 1, 2, 3 and so on. And the scale reading is the distance from peak to peak from 0 to each Stokes line. So for example, you can see if I take the first S1, then the distance from 0 to S1 is 1 itself. Okay, so for the graph, I'll be explaining using some examples. So I'll take the scale reading 1. Now we'll plot the scale reading in the x-axis and see where it coincides with the calibration curve, and then whichever value of y coincides with it will be your wave number value. That is, for 1 we get it as 20 exactly. And then another example, 6.1. So 6.1 lies around here. Comes around 115. So now we are done with this graph, and from this graph we have got the values of the wave numbers. And now using this table we are going to plot another graph which will be a wave number versus J graph. So in the x-axis we are writing the J values, and in the y-axis we are writing the wave number values. And with the help of the table you just plot the points corresponding to J and wave number, and you should get approximately you should get a straight line, and then you draw and you find the slope. So we'll find the slope using this, that is AB by BC, which is equals to 4B. So in our case the slope is come as 3 by 4, that is 7.5. So B will be equal to 7.5 divided by 4, that is coming out as 187.5 meter inverse. Like I said in the beginning, you substitute the value of B here, and then you get the value of the moment of inertia. Next part of the experiment is first to find the reduced mass, which is given by M1 M2 by M1 plus M2 kg. So since we are dealing with nitrogen, M1 is equals to M2 is equals to 14.00308 U. Since it's given in U, we need to first convert it into kgs. So we need to multiply it with 1.667 into 10 to the power minus 27 kg, and then put it in the formula. So the next part is to find the bond length, and the formula is quite simple, that is root of I by mu, that is I is the moment of inertia that we have already found, and mu is the reduced mass which we have already found out. So these are the results that we get from the experiment. The value of rotational constant B we get from graph. Moment of inertia, we substitute the value of B into the formula to get this, and the values of reduced mass mu and R0 are simply by substituting in the given formulas.